Hey, what's going on, guys, and welcome back. We are continuing the course. We are starting part 3 in this video. We're going to try and do most of this first section, but after giving it a preliminary look, we might have to split this video into either 2 parts or maybe even 3 parts just to cover this first section. Again, the goal is to condense these videos into 20 minutes, 30 minutes at most. So we read the material, we do the exercises, submit the exercises, and just move on in at least 20 minutes. So you can have time to go do anything else that you need to go do in your day, and you don't have to sit here with me watching, a 2-3 hour long lecture video about this course. One thing that I do want to mention is just as like an FYI or just a note for you to look out for. So this course, I should have mentioned this, but this course is a couple of years old. And by that I mean it's not that the material is a few years old, but it gets updated year over year. So you can find the material from 2025 by if you change this number up here, programming dash. If you change it to 25, it will show you content from 2025. You can go back to 2024, 2023, and so on and so forth. So just make sure that when you're doing, sometimes you might access the course from Google. So you might look up University of Helsinki Python programming course, and then hit enter on Google. And it might send you to the 2025 or 2023 link, but it might not send you to the 2026 link. So just be careful that when you are doing the course material, that you're on programming-26. That is the latest version of this course. They update the material and some of the content, the grammar, formatting, exercise issues, any bugs that people report. They get updated year over year. So just be careful that you're accessing the programming 26 link and not 25, 24, 23, or any one of the previous links from the previous years, which I think might be the cause that where sometimes when I'm doing these videos and I'm submitting the exercises, when I go back and check, that we've done the exercises to prepare for the next videos, I notice as some of the exercise submission boxes are empty. And I think that's probably what the issue was that I was accidentally accessing a previous year's link and not the current year's link for the course. And when I'm submitting those exercises, and I come back to check later, and I check on TMC to see how many exercises we've completed so far, and sometimes I'll see like part 2 sections will be missing or part 1 sections are missing, and that's because I was accidentally accessing the wrong link. So if you want to make sure that you've been submitting your exercises to the right course year link, you can try on TMC, right? Go to tmc.fi/org/MOOC/courses, and the course number is 1640, and just scroll down and see that you've submitted all the exercises up to exercise 22 from part 2, which was the last exercise that we did in the previous video covering working with numbers. So that's just something I wanted to let people know, that sometimes you might be accessing the wrong course link. It might be a previous year's course link and not the 2026 course year link. So just make sure that you're on 26 one. So when you submit these exercises, it is reflected on your test my code view. Okay, so part 3. I wanted to get that little bit of yap session out of the way. Okay, so part 3 is more lessons and exercises focusing on loops. So in the previous section on part 2, towards the end, we covered simple loops, right, using while loops. So in this one, we're gonna dive a little bit deeper and learn more complex loops and how to work with loops a little bit more with Python. So we're gonna be doing section 1 in this video, like I mentioned before. Hopefully we get through at least half of the material. If not, I'll split it up into several chunks so that we can keep these videos around 20 minutes long, and continue with the course. So today, in this video, as far as I'm aware, we're going to be able to do at least half of section 1. This is the list of exercises that we expect to do. I took a quick gander. I think it's about like 35, I think, exercises in total. So, and then at the end here, it's that feedback quiz that I was talking about, that we've seen a couple of times. Just do it honestly. I think it's one of the, we're getting this extensive college level material for free. These feedback exercises quizzes that you might see scattered around the course are really useful for the university to update the material accordingly to address any errors, any bugs, any typos, and stuff like that. So I think you should do them. So part 3, loops with conditions. This is section 1, loops with conditions. And the learning objectives for this part are as follows. It says after this section, you will know how to create a while loop with a condition. You will know what roles initialization, formulating a condition, and updating variables perform in a loop. And you will be able to create loops with different kinds of conditions. Here there's a note about the exercises on this course. It says becoming a proficient programmer requires a lot of practice. Facts. I got my computer science degree like 2 years ago, and I'm still learning every day. The industry is fast paced. It changes like every day almost. It changes every month. It changes every year. New technologies come in. Old ones are replaced. Packages and dependencies get updated all the time. Many get abandoned, right? So practicing is everything. You got to stay on the know, and to become a really good programmer, you have to practice a lot. So, and in these videos, when I'm filming these, when I'm recording these videos and doing these exercises with you guys, it's me also getting a lot of practice. So that's why I find a sense of enjoyment doing these videos, and I've gotten some feedback from you guys that people are enjoying these videos and they find a lot of use for me making these videos, and I'm truly grateful that you guys are able to find some value from these videos. But this is once you get into the industry, if you commit to becoming a programmer, a software engineer, or whatever, you will know that the learning never stops in this industry. Sometimes even quite mechanical practice. It also involves developing problem-solving skills and applying intuition. This is why there are a lot of exercises of different kinds on this course. Some of them ask you to write straightforwardly, apply what you have learned in the material, but some of them are intentionally more challenging and open-ended, which you can see that when we submit our solutions and compare those solutions to the model solutions that the university has submitted, you can see that they differ a little bit. And that's one of those things, those fun things about programming. There's so many ways to do the exact same thing, right? There are so many languages that you can use to to reach the same output, the same look if you're building like a piece of software or something like that. Now, granted, each programming language has its benefits, its pros and cons. One might be faster than the other when it comes to compile times and whatnot. But this is what programming is. It's very open-ended. I can give 10 different programmers the exact same challenge and tell them to go just figure it out. Like use whatever language you want as long as it looks or does these specific constraints, and they'll be able to do that because programming and software engineering is very open-ended. Okay, some of these exercises might at first seem overwhelming, but this is nothing to worry about. None of the exercises is strictly mandatory, and in fact, you only need 25% of the points from each part to pass the course. You can find more details about passing the course on the page on grading. And that is true. That's why if you don't submit enough exercises, I think I mentioned this in one of the previous videos, it might not let you progress. So as long as you do 25% of the exercises that you come across, you should be okay to pass the course. But I just recommend doing everything because you can never get enough practice being a programmer. Just do as many of them as you can. Do them on your own, right? You can pause the video, go through, after we read the material, you can pause the videos, go take on these exercises on your own, see what solutions that you come up with, compare them to mine, compare them to the model solution that the university has up. But yeah, so this is one of those points. You only need to do 25% of the course material to pass the course, for each part, that is. The exercises are not in any specific order of difficulty. Each section usually introduces some new programming concepts, and they are then practiced with both simpler and more complicated exercises. If you come across an exercise that feels too difficult, move on to the next one. You can always come back to the more difficult exercises if you have time later. When the going inevitably gets tough, a word of consolation, a task that seems impossibly difficult this week will likely feel rather easy in about 4 weeks' time. So yeah, sometimes just walk away from it. Walk away from that challenge that you're facing right now. Go, do something else, distract yourself, and then come back and take a fresh look at things. These are some of the issues that you're going to come across in the industry a lot. You might have some tasks at work that you have to do. The first time you try to complete that task, whether it's implementing a new feature, updating an old feature, refactoring code, et cetera, et cetera. Sometimes you just have to, you might come across a problem that's too tough to overcome in that moment. So being able to take a step back, distract yourself with something else, give your brain some time to reorientate itself. I guess that's for lack of a better term, and then come back to that challenge and see if you can take it on again. Programming is very self-paced, so it just takes a little bit of ambition and motivation to continue to want to advance. All right, so here we go. This is the actual meat and potatoes of this section. So in the previous section, we learned to use the while true loop to repeat sections of code. In that construction, the condition of the loop is true, so the condition is fulfilled every time. We needed to explicitly break out from the loop each time to avoid an infinite loop. For example, so this is a sample program. Goal is to print numbers until the variable a equals 5. We have a helper variable defined outside of the while block. We set a equal to 1. Then we say while true, print a, then increment a by 1. And then if a equals 5, break out of the loop. So it'll print 1. So here it prints out what the program is gonna output. But essentially, we set a to 1. We're going to print 1, like we're doing here. Then we're going to increment a by 1. Then we're going to check if a equals 5. So a, when it gets to here, a is now equal to 2. It's asking, is 2 equal to 5? No. So we go back to the top. We print 2. Then we increment a to 3. Then we check, is 3 equal to 5? It's not. We go back to the top. We print 3. Then we increment by 1. Then we check, is 4 equal to 5? It's not. Go back to the top, right? Print 4. Then increment 4 by 1. Now it's checking, is 5 equal to 5? It is. So we break out of the loop. So that's how you get 1, 2, 3, and 4. Of course, the condition doesn't always have to be true, but instead, any Boolean expression can be used as the condition. The general structure of the while statement is as follows. While some condition, do that. The idea here is that the execution goes back and forth, checking if the condition is true and executing the code within the block over and over again. If the condition at any point is false, execution of the program continues from the line after the while block. So here we have our code reaching the conditional block, right? Checks the conditional statement. If that condition is true, go execute all the other code outside of our block. I mean, if it's false. If it's true, then do what's inside of that while block and then loop back every single time until we reach our terminating condition, right? If our variable equals a certain value, et cetera, then we exit that while block and go continue executing the remaining lines of code in our program. In the following loop, we have the condition number is less than 10. The block within the loop is executed only if the variable number is less than 10. So here we have a helper variable which stores an integer called number. Then we check while number is less than 10, print that number, and then increment number by 1. So if we type in, so here's how the program will look if we start with the number 4. So we set number equal to 4. Then we see, well, number is less than 10, print number. So 4 is less than 10, that's true. So we print 4, and then we increment 4 by 1. So so now our number becomes 5. Then we check number 5 is less than 10, it's going to print 5, then increment up to 6. Then 6 is less than 10, and so on and so forth until we get to 9. Right? When it's checked 9 is less than 10, it's true, so it prints 9. Then it increments 9 by 1. So number becomes 10. Then it checks, is 10 less than 10? No, 10 is equal to 10. So we're not going to execute this because we've reached that terminating condition. And then it's going to print execution finished. In this structure, the condition is always checked before the block within the loop is executed. It may happen that the block never gets executed like so, right? If we give a number that's greater than 10 as our starting number, like 12, for example, right? It's going to check, is 12 less than 10? No, 12 is greater than 10. So it's not going to execute what's inside this while loop. It's just going to go straight to executing this final print statement that's going to print execution finished, which is what this code or this sample output print is telling us. So yeah, 12 is not less than 10, so the program doesn't print out a single number. Initialization, condition, and update. To create a loop, you'll often need to include 3 distinct steps: initialization, condition, and updating the iteration variables. Initialization refers to setting the initial values of the variables used within the condition of the loop. These are often called the iteration or iterator variables. Also, as we learned in the previous section, are also called helper variables. This is performed before the loop is first entered. The condition defines for how long the loop is to be executed. Actually, pardon me, that's not what a helper variable is. A helper variable will be one that keeps track of certain values that we might need to use after the while loop is executed. So that's a correction on my part, right? So we might need to track how many positive numbers that we go through, right? So we'll set an additional variable called a number of positive numbers or something like that and set it equal to 0. And so even numbers or positive numbers. So every single time we encounter a positive number, or if we're tracking even numbers, we'll increment that helper variable. So that's what a helper variable is. I have been misusing that term, but it just kicked back into my brain. So initialization variables are not the same as helper variables. And sometimes they could be. They could be one and the same, but that's usually not the case. But yeah, I just wanted to make that clarification. This is performed before the loop is first entered. The condition defines for how long the loop is to be executed. It is set out at the very beginning of the loop. Finally, within each repetition of the loop, the variables involved in the condition are updated, so that each iteration brings the loop one step closer to its conclusion. The following image illustrates these steps. So this is coming from the previous example that we saw above. We have this initialization variable, or the iterator variable, so called number, right? So we're going to use this variable in our condition check. So while number is less than 10, which is our condition, then we want to print out the number, and then we want to update that number so we can reach the terminating condition, right? So we can get out of this loop eventually. If we don't increment, it's just going to keep printing whatever our number is over and over and over and over and over again, because number is going to be whatever our initializing value is, right? If the number is 4, so it's going to check number is less than 10. 4 is less than 10, yes, print 4. Then go back. 4 is less than 10, yes, and that's going to keep you in an infinite loop. So we need a way to update our variables, and we do that inside the while loop so we can reach that terminating condition faster, and then we can break out of the loop when we reach that terminating condition. If any one of these components is missing, the loop will likely not function correctly. A typical error is omitting the update step, right, which was what I was just talking about. So we have our initialization or iterator variable here, number equal to 1, then we check, well, number is less than 10, print the number. But because we're not decrementing or incrementing that number to reach our terminating condition, we're going to stay inside this loop forever. It's just going to keep printing 1, 1, 1, 1 over and over and over until you run out of memory. So here the value of the variable number never changes. The program is stuck in an infinite loop. And the exact same bit of code is repeated over and over and over again until the user stops the execution, for example, by pressing Ctrl+C. So here is one that's going to get printed over and over for infinity. Okay, our first exercise. It's called printing numbers. We're instructed to please write a program which prints out all the even numbers between 2 and 30 using a loop. Print each number on a separate line. The beginning of your output should look like this. So 2, 4, 6, 8, etc. up until you reach 30. So, okay. So we need to track our number. So we're just going to say a number is equal to 1. Then we're going to need while number is less than 30. Actually, we should probably set it equal to. Then we're going to say if number percent. We're going to use the modulo operator. We came across this a while ago, but this is going to return the remainder from doing the division of dividing a number by 2. So if the remainder from a number divided by 2 is 0, then we want to print that number because that's what's telling us that that number is an even number. Then we're going to need to increment number by 1. So let's run this and see what it does. It prints 2, 4, 6, 8, 10, 12, 14, all the way down to 30. All the even numbers from 2 to 30 inclusively. So let's test this. And there we go. We can also view the model solution. And they did the same thing. So they started at 2, and they went up to 30, and did the same thing. But they incremented by 2. So they incremented by 2. We just checked if whatever that number we're currently at divided by 2 is a positive number. It doesn't have a remainder. And then just to print that number. And so these two codes blocks do the same thing. Remember, like what I mentioned earlier, right? Programming is open-ended. We've done these same exact exercise as the programming, as the university submitted, and we came to 2 different solutions that do the exact same thing. This one's a lot more straightforward, right? Start at 2, check if a number is less than or equal to 30, print that number, then increment by 2. We check if our number divided by 2 returns no remainder, then we print that number. But yeah, that was pretty straightforward. And we just hit the 20-minute mark. So I think this might be the last exercise that we do. And it actually beautiful because there's more readings here to do. So we'll leave it at here and we'll continue. I needed to reset this because I did take a look at these exercises before I started recording. So we'll do this exercise and then we'll break the video there and then we'll do the remaining readings and exercises in the next video. Okay, the program below, this one is called Fix the Code Countdown. The program below has some syntactic issues. So we're first prompted to print, and it prints, "Are you ready?" Then we're prompted to enter a number. Then we have a loop here. And then we print the number and print now. So it says, please fix it so that it prints out the following. It prints, "Are you ready?" Then prompts us to enter a number. Then it's going to print whatever number we enter down to 1, and then it's going to exit the loop and print now. So this is what the code currently looks like. If we run it, let's see what we get. It says syntax error on line 4, invalid syntax. So what's going on line 4? This is where we put where our loop starts. So while number equals 0, and then we have a block. So we know we're going to have to print out the number. But this can't be true. We can't be right because we need to print numbers down to 1. So we have to say while number is greater than 0, print number, right? So if we give it 5, it's going to print 5. Then we need a way for us to decrement that number. You can do number is equal to number minus 1 or number minus equals 1, like that for shorthand. So it's going to print that number. So let's run this and see what we get. If we start with 5, 5, 4, 3, 2, 1, now. So again, what is the code doing? We first print, "Are you ready?" Then we prompt the user to input a number. Then we have our loop with our condition here. So this is, if you remember the parts of a loop, the number variable is our initialization variable or the iterator variable. It's going to serve both purposes here. We're going to put our initial value, and then we're going to use this number to iterate the loop over and over until we reach our breaking condition. So we have number, we set that equal to an integer that we provide. Then we have our loop with our condition. It's going to check if number is greater than 0. Then inside the loop, we're going to print that number, and then we're going to decrement number by 1. So if we start with 5, it's going to check, is number greater than 0? If 5 greater than 0? It is. So print 5, then decrement 5 by 1. So number becomes 4. It's going to check, is 4 greater than 0? It is. So it's going to print 4. It's going to decrement by 1. Is 3 greater than 0? It is. Print 3, decrement by 1. Is 2 greater than 0? It is. Print, decrement by 1. Is 1 greater than 0? It is. Print 1, decrement by 1. And then it's going to check, is 0 greater than 0? It's not. So nothing inside the loop is going to get executed anymore. It's going to come down here and print now. So that's what our code is doing, and that's how we get 5, 4, 3, 2, 1 now. So if we test this, there we go. Let's view our model solution. And yeah, same thing. Print, "Are you ready?" Prompt the user to input a number. Check while number is greater than 0. Print the number, decrement by 1, and then the final print statement. So that's the solution for those two exercises. We're going to do this reading and the remaining 1, 2, 3, 4, 5. So maybe we'll get through the remaining 5 exercises in the next video. If not, we'll probably have another short video covering the last batch of exercises here, or the last actual single exercise. So thank you so much for watching, and I'll see you guys in the next one. Solutions will be up on the GitHub repository. If you want to skip, if you don't care about watching the video and just want to get to the answers, those solutions will be up on GitHub. Make sure you check the link is in the description to the repository. Please give the repo a star. Please give this video a star. I truly appreciate all your support. Thank you for the feedback and the comments encouraging me to keep going and make these videos that people are finding great value from them. I appreciate that feedback, and I will continue to make as many videos as I can so we can get through this course. So fingers crossed we actually do finish this course in due time. But yeah, I'll see you guys in the next video.